Hello, I'm Layne Hartsell with the Korea IT Times, and I'm here with Oliver Sampson, computer scientist and AI and data scientist. Hi, Oliver. How are you?
Hi, thank you very much for having me.
Yeah, it's nice to see you. I should say that Oliver and I went to high school together and also to college together at Virginia Tech. And then he
That's
moved
right.
to Germany to complete a PhD, has been working in Germany ever since 1998. I guess it's been a while now.
That's right. It's been a
Uh,
long, long time.
Yeah, well, I'm happy that you have this expertise and that we had a chance that we could get together here. And actually, it's too bad when I was in Berlin that we didn't get a chance due to COVID. Um, let's talk about artificial intelligence, okay? Because at the end of the or at the beginning of the summer, I had written to you about the idea of AI being sentient, and we had a few email exchanges, and we were talking about this, and we I thought, well, it might be good, to hear from you what your opinion is and what is the current state of AI and data science.
Well, that's a extremely broad question. I think it might be a good idea to start with that sentience thing. So sentience thing that started when that engineer from Google decided that he wanted to publicize some conversations he was having with a particular language model called Lambda. And he had become convinced that this model had become sentient, and he had expressed concern about how this model was being treated and what he this explosion of news that came out, this amazing publicity, if you will. And so there is no such thing as bad publicity in this case for Google either. This
Hmm.
explosion of publicity that happened behind this Lambda model before this engineer, I've forgotten his name, finally got fired. So um, the short answer is there is no doubt that this model is not sentient, and there's a very simple reason for that. Is that there's a big difference between emulating and simulating. What these language models do is they simulate types of language structures, but they do not emulate. They are not creating their own way of thinking through some type of other process. So
Got it.
that part of the philosophical question is very easy to answer, and it's done. Now, there are much harder parts of this philosophical question to answer. For example, what does sentience mean? What does consciousness mean? What is intelligence even? What is, when we talk about artificial intelligence, and there's a lot of hand waving, and there's lots of it, and it's been hand waving since the creation of cybernetics from Wiener way back in the 40s. There's just a whole bunch of things where people just kind of wave their hands, and like I do here all the time, wave their hands and sort of say, well, this must be intelligence, and intelligence, it's sort of like pornography. You know it when you see it. The classic description from the Supreme Court back in the 70s, right, or the 60s. The thing is that sentience is a very difficult thing to really grasp, and even intelligence is a really difficult thing to grasp. This goes way back to Descartes with cogito ergo sum. I think, therefore I am. Well, that sort of sounds like circular reasoning to me. When we talk
That
about
makes sense.
sentience, there are lots of things where we describe what makes someone sentient. It's being self-aware. Well, gorillas are self-aware. Elephants are self-aware. Porpoises are self-aware. Are they sentient? Elephants grieve their dead. That sounds like they are aware of being not aware of being the absence of it. And so, we don't really have a good definition of sentience. We don't really have a great definition of consciousness, and we barely have a really good definition of intelligence. We that's why it's really funny that we even talk about artificial intelligence. So I think it was really great that we started this conversation when that news broke. But I really want to make sure that it's very clear that this Lambda model and the current large language models that are happening and that are making amazing progress, really, truly tremendous things are happening in large language models today. They are not sentient. Let's get that out there and just put that stake in the ground. And it's going to be a while before, if ever, if we ever have a sentient machine. And then before that happens, hopefully we'll have a good idea and a good definition of what sentience is. So And then
Okay,
as far as the
so
state of, oh, I'm sorry.
intelligence. Yeah, intelligence.
Yeah. Well, as far as intelligence goes, when artificial intelligence came about, they there was a bunch of smart guys, and they were playing with their first computers, and they had lots of vacuum tubes, and they had large machines that filled up something that about the size of a basketball court, a basketball gymnasium, and
This
they
reminds me of
they
you in high school.
yeah. Well, I mean, really, this is the real
Close.
deal. My father worked with these types of systems when he
Yeah.
was doing stuff for the military. But the point is that they defined intelligence and artificial intelligence to be the things that they thought were difficult. That's why really one of the very first problems that they tried to solve is playing chess. Chess is kind of stereotypically an intelligent person's game, and the people who play chess well are usually regarded as being intelligent. There's some sort of correlation there. I don't know how strong that one is in particular, but there seems to be a correlation there. And so they thought, if we could create a machine that plays chess, then that would mean it's smart. Well, it turns out that we now have superhuman capability in chess playing, much like we have in Go, and we have in playing some Atari games, and we have computers that are able to perform at superhuman abilities in these things. Does that make them smarter than humans at all? Well, no, it makes them better at playing chess or Go or Atari or whatever it is. It's not necessarily a sign of sentience or intelligence or consciousness. It's a very particular skill in a very narrow area. Then it is it's a narrow type of intelligence, and we have machines or programs or algorithms, however you wish to describe them, that do some narrow things very, very well. And of course, over the last month or so, maybe 2 months, all of the work that's come out in generative models, so these things where you can push a couple of words into a web browser and then out comes some remarkable type of a picture or something, these generative models, this is
called
amazing. So Dali
Dali?
was the
Yeah.
one that really started to pop out, and there's been a couple other ones using a particular type of deep learning architecture called diffusion. And there's been a couple of others that have come out recently, and they're doing, I mean, if you've seen any of these pictures, they're truly remarkable. There's really amazing things, and they seem to show types of originality. They seem to show types of connections of putting different ideas together, but that's our interpretation of this artwork. It's the artwork. It's not necessarily, it's not random pixels, clearly, because there are pictures of people or windows or dolphins or whatever. There's but when we look at the picture, then we sort of we are interpreting it, and then we create sense of feeling towards this artwork. And that's the way it is with any type of artwork. If you decide you can look at a tree, is the tree beautiful? Well, the tree wasn't designed to be beautiful. The tree ended up being a tree by itself. And so the same thing with these pictures that are coming out is that if you find them to be remarkable, that's because you are finding them to be remarkable, not because they are necessarily remarkable in and of themselves. And so,
okay, so for people that are listening, what you're talking about is I type into the to the browser or whatever, I say to Dali 2 squared or whatever it is, I want melting clocks with dolphins jumping over the rainbow, and it will it will make the picture
exactly right. And then one of these pictures, I think it was a guy, it doesn't matter, some artist took some description, put it into, I think it was Dali, but it could have been a different one, did some other post-processing to scale it up and make it a little bit more believable, a little bit more fancy stylistically, created a large image out of it, printed it out on canvas, and it won first place in an art show somewhere in the Midwest, I think. And so, and then of course the thing is that, well, what does it mean for it to be art? Is it possible to have a machine that makes art? Well, of course it is. We have machines that make art. We have things that people think are art. And but the thing that makes it art is the person looking at it, not the thing making it.
Right.
Right. If you perceive it as art, then it is art, even if it is. We had this stuff with music, right? There was a big controversy back in the 60s when free jazz came along. And if you are uneducated in the vocabulary of jazz, free jazz sounds like a bunch of kids knocking, toys together, and just making noise. And so, well, and truly, and there was one of the critics of free jazz back in the 60s. He said he was going to put together a free jazz band. It was going to be fantastic, and he had a curtain or a screen in front of the stage, and the band began playing, and of course it sounded like children smacking toy instruments together, and of course the audience in the back in the beatniks with their berets and their mustaches and smoking their cigarettes in this cloudy smoky jazz club. Oh wow, this is really great. You can really hear the trying to get the freedom away from the structures of music. And then he pulled the screen away, and it was actually children banging on toy instruments. And so then of course I was like,
what I thought what was coming is going to be like Herbie Hancock or something.
No, he joked and he played the entire audience. Yeah. So does that make their perceptions of it being art any less valid? Or were they just being pretentious and pretending to think that it was art? I mean, there's a lot of philosophical questions that are involved in this, but in general, if you an observer see something and you say, I like that, then that alone is valid, period. Right. And that goes for anything. Right. And so the fact that we have machines that can create very interesting, very artistic, very, very images that are complex enough that we could interpret them in ways that we feel something, some emotional connection, even though there are no emotions being created by that device at that time, that doesn't mean it's less valid. It's just a different way. It's a different tool of creating things. There's electronic music that has been algorithmically created, and a lot of it is basically crap. But every now and then something pops up, and you go, "Oh, that's kind of interesting." We have this today. You can go to YouTube. There are YouTube videos which are forever. There's just an algorithm in the background generating new music or based on other music, and you can listen to them today. Most of them sound like crap, but but it doesn't. Oh, I'd have to go find the links. There's different YouTube ones. There's one of the forever bass solo and the forever drum solo and the forever guitar solo.
I got it.
And things like that. And they're basically, and you can hear where they're copying whatever they ingest an enormous amount of data and ingest an enormous amount of number of bass solos, and then create this sort of fake bass solo on the way out of it. And it's basically as good as any bass solo you've ever heard, which means probably not very.
Better than mine.
Guitar solos. Yeah, it's better than and so, but it's that doesn't mean that it's not a bass solo. It just means that it's probably not very good, or it just means that if you find it good, then that's great. That's your interpretation, and the same thing goes for these generative models that are happening right now. That's really today the big thing that's happening in the artificial intelligence world are the generative models, which is actually have basically eclipsed the news that was happening of large language models, which was up until 2 months ago with the Lambda thing with from Google, was really the big news happening in the artificial intelligence world. Yeah. So yeah. It's been an exciting summer. It's been an exciting summer in the world of artificial intelligence. For sure, yeah.
Well, if we look at let's take Alan Turing, right? So we go back and to look at like classical AI and what people were talking about. So let me throw this out here. At that time, we were projecting the human beings. They're projecting onto the computer. It has memory, it has intelligence, so forth and so on. So Turing would kind of jokingly respond, or said that, do we ask that submarine swim, right? So the machine and the intelligence are not the same thing. As this is a projection that we have. What happened, interestingly enough, is probably by the 1990s and so forth. Not only was AI and computer science and all of that doing this, but also in neuroscience. What happened is it started to project this back onto the human being. So it projected machine like characteristics back onto the human being, which is a very dangerous thing, in my opinion. What do you think about this? What do you think about Turing's statement and in AI in this context?
Well, so the most famous thing about Turing is the Turing Test, right? So the Turing Test basically says that if we can have a conversation that passes for a human being, that means the machine has something that seems like human level intelligence. And so we've done that. That exists today. These large language models truly create types of conversations that if you didn't know that they were coming from a machine, you could really believe that someone had, of their own free will, typed those words in that order in response to these questions. So but again, that is not emulation, that is simulation. Similarly, we have, there are research and current research in natural language processing where they try to do something called understanding and problem understanding. And that's do submarine swim. Given a text, is it possible to ask questions of the text that require logical inference and maybe some background knowledge in order to make sure connections between different parts of the text? So one of the things that's actually really difficult in natural language processing is following pronouns. If you read a text and you get to an it and a they and a you and a he or a she, any of these pronouns, we people who speak language naturally, that we've been programmed to do this for many decades in our cases, we naturally follow along. And then every now and then, if we're not sure what that pronoun is, we'll jump in and say, that he, was that the one guy or the other guy, or is that she, the one woman, exactly, or the other woman, or whatever, right? And it turns out that even on short text with a lot of pronouns, it's very easy to confuse a machine because it doesn't have necessarily the same level of inference and understanding of knowing this he has to be a person and not the horse, because the person is the one who has some agency and the horse doesn't, or something like that. And so,
I see.
So the next level of what you're asking about from Turing is that, yeah, that's really generally a hard problem, and it is still being worked on, and we're seeing slow or even large leaps in that right now. Actually, I have on my to-do list. That's one of the things I need to start looking into for a lecture I'll be preparing for in January. And so I expect to be fully up to date on this topic before too long. But we're making leaps in that area. But this really sort of large cognitive understanding of how to infer information based on separate pieces of information to induce information, that's not quite as far along. That's different from what we're seeing, these remarkable text generative systems. That's a completely different ballgame. So
right. So the Turing test we've already solved, but it's not not emulation, it's simulation, you say.
Right. That's right. So the Turing test, so we can convince people that they are talking to people. So chatbots, anybody who's been had to interact with some service thing, they get asked if they want to use a chatbot. Now, if you've ever used one of these things, your experience, the expression is your mileage may vary, because the ones that I've used have basically been horrible. And then,
right, I play with them sometimes. You can tell.
They're generally horrible, right? They're basically we had this goes all the way back to the beginnings of artificial intelligence. It was the Eliza program. And so I remember back in high school going to a buddy's house, and he had, he was ahead of the game. He had an Apple II computer, and he had the Eliza program on the 5.25-inch floppy drive, and and it was really cool because we would play with this program, and he'd say he had the source code for this program also, and so if you can trigger this answer, it'll get you into this whole other part of this question and answer game. And we would try to see if we could manipulate the program into getting into other parts of this Eliza thing. And so, but this goes all the way back to the very beginning. Chatbots are one of the oldest things. I mean, the conversation, language, that's what smart people do. That's why the fathers of artificial intelligence way back when, they thought, oh, well, if you can create a chatbot, if you can have language, if you can play chess, this is a sign of intelligence. And of course, it turns out that you can simulate that very well if you give it enough data and given enough parameters. These large language models, they are truly enormous. You or I, we could never afford to create one of these models. This is something you have to have a giant giga corporation behind it with racks and racks and racks of GPU servers training this model on the entire the every written word that's ever been written by mankind. And then it creates a model. Then now, of course, the smart part about this is that how that model looks and the structure of the model, this artificial neural network. But these models have become really so a trillion parameters. This is unfathomably huge. This is gargantuan. And the amount of I used to be a deep learning skeptic. When deep learning really broke into the presence, it was 2012, what's referred to ImageNet, and so it was really a inflection point. And that was the reason for that is that deep learning was able to make a huge leap in what's called the ImageNet classification problem. So there's a standard data set, and they use for tests, and they use for creating benchmarks. And there had been slow improvement in saying, if you've looked at this data set, they have pictures of a chair, they have pictures of a cat, or they have pictures of an elephant. And they say, well, they recognize this as being a chair, recognize this as being a cat, or as this an elephant. And then in 2012, this suddenly got, instead of just a little bit better, it got a lot better. And the main thing that deep learning brought at the time was that instead of having data scientists sit and try to figure out which of the features are the best, or how do we make inferences about which features are really good. So, for example, up until 2012, if you recall back when people used to use Facebook, is that they would have a face recognition thing, and they would say, this looks like a face. And the reason it looked like a face is because most faces are generally similar. There are two eyes, there's a mouth, there's a nose, ears, right. Maybe you see the ears. And so they would look for a T-looking structure in these pictures, and then maybe a T, the eyes and the nose, eyebrows maybe, and then they would look for a round thing around this T, and if they found a round thing around a T, this was a face, and then they would put a box around it and say, "Is this your buddy?" Mark him in the thing. So this was the state of the art until deep learning came along, and what the magic of deep learning is that you don't do a real feature analysis anymore. You just throw it all. You put everything, all of your data into the blender, and you let it blend, and then you actually you make copies of it. So you don't just have a picture of a cat. You have a picture of a cat rotated 1 degree all the way around until it eventually becomes ground up in the blender, and then on the output, whenever you put in an image of something that looks similar to a cat, it says, yes, this is a cat. So at the beginning, I thought I was kind of a deep learning skeptic because it didn't seem like it was working smarter. It seemed like it was working harder. It seemed like it was just taking the biggest hammer you can find and slapping it on the problem instead of saying, how do we think intelligently about solving these problems? Well, as it turns out, I was probably wrong. It turns out that some of these large models are very, very good at what they do. And the thing that changed my mind it's been a couple of years now, was when transformers first came out. There's a particular architecture in deep learning called transformers, and they are the basis of these large language models that we talk about. That these things that are happening with the like the lambda the discussion. So they came out of natural language processing. They came out of this sort of the text generation. They came out of this text understanding world, and they wanted to create sort of relationships between different worlds and using very, very, very large data sets. Well, this transformer architecture, so natural language processing was sort of like the bastard child of artificial intelligence for a long time, because everything was going into image recognition, recognizing because of 2012 deep learning, ImageNet. Is this a car? Or, you need to do computer vision in order to be able to do autonomous driving. And so all of this world, everything was concentrated into computer vision, and everybody had forgotten about natural language processing until transformers came out. And there's this remarkable progress that they've done. And now they're using this architecture on images. Now they're using this architecture, so it's gone the other way. Everybody's looking to natural language processing for insight. And so there's so language is inherently a time series, a time type of information. We talk in linear fashion, and it takes time. And even though we have inflection of our voices, the technical word is prosody, but we have rhythm and we have pitch. But in general, and that conveys information, but not much information as the words we use. And so it's inherently a time series type of information. And now this is being used in order to do time series analysis on things like whatever, like the noises that a gas generator makes. And if it starts making funny noises, then there's time to go
right.
to
It can hear like a little bit, or exactly. Like a sensor, like for like a artificial nose, right? Like a nano nose can sense chemicals, like in a subway or something.
Yeah, no, that's not quite time series related.
That's not the same thing. The processing of the data is not okay.
Yeah, it's not necessarily time series. Is the relationship between different things or patterns that happen along in time. And so these things these are in your car. Your car is basically a collection of several thousand sensors and many microcontrollers networked together to create some sort of hopefully safe device for you to transfer yourself from one place to another. Same thing with airplanes. Airplanes are enormously complex devices, and there's lots of sensors, and there's a lot of information being processed. And now we have very, very clever time series analyses that are being done using deep learning architectures that were based on natural language processing. Very, very interesting stuff.
And actually, when you said that about airplanes, I was on a flight from Nagoya in Japan to Seoul, to Incheon, and we taxi over, everything's fine. We start to take off, and we're like halfway taking off, halfway down the runway, right? So maybe 130 miles an hour or so at this point. And all of a sudden, the pilot stops the plane. All of a sudden, you hear the thrusters go down thrust, and he says, "Oh, the computer, basically it's artificial intelligence, right?" He said, "Oh, we have to reboot the computer." So we went back around, came back around, and took off again.
yeah, I would have thought I would have asked to get gotten off the plane. For anybody who's ever worked in the automobile or the aviation industry, it's really it's really frightening stuff. Watching car software be developed is truly, they say, you don't want to go to the butcher and see how they make sausage. This is kind of the same thing. I worked at doing software with cars for a little while, and it's really, I'm not going to buy a new car for a very long time. I like my old car. It's from 2007, has some electronics in it, but I don't want a new car right now. I don't want untested software. It's just because it has very little to do with artificial intelligence. It has more to do with the artificial intelligence. The programmers working on this. It's like, oh wow, because the systems have become so complex, and there are so many requirements, that are almost working against one another, right? You want to have high performance, but you also want it to be very safe, and you want it to be cheap. And so you have different requirements that are working against one another, and you have software designers that are trying to fulfill all of these things. And so it ends up being, well, I'm going to stick with my old car. Hopefully, I'm not sure that these requirements are necessarily in my best interest. So, and airplanes, of course, have a much higher level of safety, much higher level, and that are much more complex devices. And it is amazing that and I am thankful to all of the software designers. If you're looking at this right now and you work in the aviation industry, thank you very much.
Thank you.
That flying is as safe as it is. And so I say, so if you had an airplane where the pilot said you had to reboot the computer, and that was probably information he shouldn't have shared with the passengers. More like, we've noticed that we have a maintenance issue. We're going to go back and have it checked out. And that's something a little bit more vague.
No, that's
Because
what
anybody
that's
who's
what he
working,
said. I kind of laughed at it.
oh wow,
I
oh
kind of laughed
wow,
at it. I
yeah,
thought, well, I think I said to my wife, there's the AI or something like that, Molly.
oh no, it may, well, who knows what software they were using to detect that problem. But there was a sensor or a message that arrived that said we have to change something. So that's
I'm sure they have redundancy in these systems, right? So I'm sure that they could have taken off and come back. But at this point, he was like, well, I'll just stop and reboot the computer. They can
yeah.
fly those machines with different ways. As we end up here, do you see any real risks with AI? Some people think it's going to take over the world and kill all the humans, and other people are like, no, it's more mundane. What are your
Right.
thoughts?
So I much like with the earlier discussion about sentience and consciousness and things like that, there's a lot of talk and there was a lot of alarmism coming from very large media technology personalities. I won't mention any names. It's not too hard to figure out who it is, who are very alarmist about the possibility of having a artificial general intelligence, or a type of what Nick Bostrom would call a super intelligence. And so the short answer is we're nowhere near that. And it's not going to be happening anytime soon. So there's no reason to worry about that.
I agree with you on this one.
Right. And even if there were to happen, so Nick Bostrom's book Superintelligence is very, very good. But even if it were to happen, what happens if this superintelligence, it decides that its whole purpose is to optimize the manufacturing of paper clips? What does that mean? Then you have a device that's
like so
all of the world's
mundane,
resources.
mean anything.
It's not there to imprison human beings into being batteries like in the Matrix, or to fight human beings and get rid of these rodents like it is in Skynet and the Terminator. Right. Turns out it's just trying to manufacture paper clips.
Just like paper clips.
Yeah, it just likes paper clips. That it's optimized from a paperclip manufacturing. It's a very interesting thought experiment. But we're nowhere near that. There's no reason to be concerned about that. What we do need to be concerned about is there are very real problems today. And that is because algorithms are being used, one, by people who don't know what they're doing. You have some person who is in I don't know, sociology or medicine or what. A lot of if we read about the reproducibility crisis in artificial intelligence right now, it's coming from people who are not practitioners of data science. It's coming from people who are other types of scientists trying to create some magic with some data science type technologies, and they're able to say, oh, this looks great, and then it turns out that it's only looks great for a very small subset of the problems, and it doesn't generalize to larger problems very well. So right. That is a problem, because that means that there are people putting artificial intelligence systems into place that should not be. So that means they're in use and they shouldn't be. The second thing is that the algorithms are just algorithms. They're just mathematical equations or types of equations that get processed in a particular order. The algorithms are absolutely, completely, in and of themselves, neutral. The problem is that the data is biased. And if you base your algorithm on biased data, then you have very, very large problems, because a lot of the data we have is fundamentally biased because there are a lot of historical problems in the world. And data is based on what has already happened. And if that data is biased, or if there were actions that were coming from before that were biased, that will show up later in the algorithms. And when people say that the algorithms are biased, well, that's not really true. The algorithms are not biased. It is the models that are created by the algorithm. The model is a representation of the world that is based on this data. And so the danger of being confronted with, or being interpreted, being used, or being predicted by an artificial intelligence model that's based on biased data is a very, very real problem that is happening today, that gets called out. You see that every now in the news, especially in things like with job interviews or loan applications or credit reports or credit scores or anything that has to do with people. It's based on people data. And as we well know, the world has been a very, very bad place for a lot of people. And that's going to show up, and that will continue to be shown in the biases until we do something about that.
So it will amplify, right? It'll amplify these biases.
It could very easily well amplify. And then that output gets creates data that's being used by the next model. And so this
Right.
type of historical bias is a very real danger of being used by models to perpetuate bias. That's a very real problem.
Yeah, well, Oliver, thanks so much for taking the time to talk with me. And I'm Layne Hartsell at Korea IT Times.
Thank you very much for having me.